There you go. All right. We are live on the Reddit Masterclasses category of RPAN. Welcome all, welcome one, maybe it's welcome one, welcome all, to the fourth installment of this streaming series that I'm doing where I go over different LeetCode questions. Well, really, it's not different LeetCode questions. What I do is my goal is to go over all of the easy questions, followed by all the medium questions, finally followed by all the hard questions. So what is my intent with all this? My intent is that if you're watching and you want some way to be held accountable for your own LeetCode progress, hopefully you can watch these videos alongside your own daily LeetCoding, and that will sort of inspire you to continue going with it. Hopefully, I'll sort of act as your buddy there, working along questions with, and my I guess another intent of mine is not really to I'm not really going to be teaching these questions as much as I'm just going to be solving them on my own, and I'll be talking about the different things I'm considering. I'll probably make a lot of mistakes, and I think that's really the best way to learn. I'm very open to criticisms and critiques. If you guys have any questions, comments, or concerns, please let me know in the chat. Some really quick things I want to address just before I resume here. Some notes I've taken from previous streams. So unfortunately, I tried looking a little bit into the mobile streaming, and there's no, at least I couldn't see. If anyone has like a good suggestion for how to do it, please let me know. I couldn't really find a good way to have this be streamed in a good way for people watching on mobile. I mean, LeetCode is one of those things that you could do on your phone, but it's going to be really hard. So really, this is meant for desktop viewing. And don't worry if you miss out on the stream this time or any of my streams because I have been uploading all of these to my YouTube channel. So you can just look up my name, Rafael Negron, and you can find all the different LeetCode streams I've done. And one thing that I've started doing that I modified today is, for example, if you go to the first one here, I also added like a list of all the questions we have, and these are ordered in the same order that I did them in the video. So let's say you're starting for the first time LeetCode, you want to sort of follow along with me. You can open up the first video here, and you can just start doing all these questions in order, and then maybe after you're done, you can just watch the video to maybe learn a thing or two or listen to something I did, and so on and so forth. So with all that being said, if anyone has questions, I'll leave this open here just in case people want to be able to watch this later. But I will be uploading this later. This one might be a little shorter than an hour just because it's a little bit more late. Today's Monday, so I had a full work day. Anyway, I wanted to get around to doing this. So without further ado, I tend to talk a lot. Let's get it going. Today we're gonna kick it off with this one here. As of today, I don't have premium anymore, which might actually be better because now this is, these questions will apply to anyone. You're not locked by a subscription, which I think is cool. So we're going to be starting today with create target array in the given order. And this looks like a question that not many people like, unfortunately. Create target array in the given order. A lot of upvotes, but also a lot of downvotes, and more downvotes than upvotes. So let's go ahead and read this and let's think about how to do it. So given two arrays of integers nums and index, your task is to create target array under the following rules. Initially, target array is empty. From left to right, read nums I and index I and enter it at index. The value nums I in target array. Repeat the previous steps. Repeat the previous step until there are no elements to read in nums and index. Return the target array. It is guaranteed that the insertion operations will be valid. Well, I mean, there's definitely one way that I can think of doing this, although I don't think it's very efficient. I'm trying to see if there's any follow-up, and I'm trying to see if, let's see, index.length is less than or equal to 100. This will only ever be 100, so that could, because this is like a very, I feel normally when we have bounds like this that are small, a lot of times you see like 10 to the 5, 10 to the 4, but this is just 100. That might mean that we can do something else than just this brute force method I'm going to suggest. So let's think about the nums that we have here. So we'll just make a comment of this just so we can have it on our editor here. And then we'll think about the indices. Imagine we just have an array that's the same size, right? So this is 0, 1, 2, 3, 4, so size 5, and we'll have, initially all zeros. So 0, we're going to put at 0. That's already good for us. And we get to uh, nums 1, we're going to place that in 1. 2, we're going to place in 2. Now 3, we're going to place in 2. So really it means that we're going to shift everything at position 2 over by 1 and then enter it to 3. That's one way that we can do it. So what does that look like? We shift the 1 over, essentially just doing that, right? Or really what we want to do is instead of starting here, we can start at length minus 1 all the way to the index, and then we'll shift this one over, and then we enter the thing here, right? 0, 1, 2, 2, 3, 2, and then 4 at 1. We do the same thing. So now it becomes 1, 3, 1, 4. So 0, 4, 1, 3, 2. I probably, yeah, I think I by accident put 2 ones in there. That's like one way of going about it, and I almost sort of just want to try it that way and see what the time complexity would be like. I mean, let's think about this. We don't really need to, can we do this in place? I guess there's like a couple different ways we can go about this, right? Let's see. I'm gonna just number them here. So let's try to do 1. I'll just call this the brute force method. 2, can we do something in place? And then 3, can we use the upper bound of 100? These are like 3 different things I'm gonna try out. But let me try this brute force method, and we'll go from there. So I'll create a new constant here. I'll call it target array. And I'm going to set this equal to a new array that's the size of nums.length. And I'm doing this just using the constructor for an array. And I think that I want to fill this in with zeros because I'm not sure. So if you don't specify fill, what this will actually do is create empty slots in the array, which are not the same as slots or indices that have values of undefined. And I'm not sure how empty slots will translate to when I'm doing the shifting. So let's think about that. Now at every step, this is 0. Like how do I know I haven't already entered it something in that index before? 0, 1, 2, 2, 1. Right, there's like a lot of things we can do here. We can even remember, because I only want to shift if I haven't ever visited that index before. And this is index is 1 less than or equal to 100. 1 less than or equal to nums.length, index.length less than or equal to 100. Does it mean that this will only ever have 0, 1, 2, 3, 4, 0, 1, 2, 3, 4? If this only ever has that, can I use that to see if we've already been there? Let's see, we're gonna be doing a couple different things here. Let's make the 2 something about like remember indices we visited. And let's go from there. So the first one is like the very brute force method. So we create this new array that's initially the size of nums.length. And now for let I equals 0, I less than index.length. That's kind of a weird thing to call. I would expect indices at least. But yeah, let's just for every single one of these, and that's just like that's almost like blindly brute force. That's like very brute force. And we might even get like a time limit exceeded for this. We're going to be shifting numbers that we haven't even, right? Like if I haven't already been there, I can just place it. So I might not even want to do this one first because that just seems crazy. So if I get to a 1, I get to a 2. Yeah, let's actually I want to go over it again with that thing that I'm thinking of. So we have nums and we have index. So 0 goes into 0. That's the first time. Now let's say I put that to negative. 1 goes to 1. Okay, been there. 2 goes to 2. Okay, been there. Then 3 goes to 2. If I check 2, I've already been there. So now that means I have to do the shifting. Although I definitely did this. I did this the opposite way. It should be, let me switch these over and make it a little bit easier for me to read. 0 goes to 1, so I've been to 0. 1 goes to 1, so I've been to 1. 2 goes to 2. Now 2, like index 2 goes, yeah, this next one goes in position 2, which I've already been to, which means here I do have to do a shift. 0, 1, 2, 3, 4. So we want this to be here. Now I'm getting all this like a little bit mixed up. Output, where are we getting this 4 from? 0, 1, 2. And now the 3 wants to be put in the 2. Okay, 2. Totally messed that up. Oh, it's because we need to, yeah, I know why. I wasn't making like my output array. 0, 0, 0, 0. There we go. Okay, indices on top. 0 goes to 0, that's fine. We've been there. 1 goes to 1, that's fine. Okay, we've been there. And index 2 goes 2. Cool, we've been at 2. Now in index 2 goes 3, right? We've already been to 2, which means that we should do shifting now. So we will shift this to, let's say we can just make this 2, 2, and then put that 3 there. Okay, and then we get to 1. So in position 1 goes 4, and we've already been there. So we should shift all these by 1. So 2, 3, 1, 4, 0, 4, 1, 3, 2. So I think something like this could work because the other way just seems way too brute force, but it might be worth it for me to also do that anyway. Let's just see. Let's do like for let, I guess just like runner index equal nums dot length minus 1, or just for the sake of like saving some space. If we do let j equals nums dot length minus 1, j greater than or equal to the current index, which in our case will be index at I, j minus minus. So we're at this one, we want to take whatever is in, yeah, and I also need to, yeah, target array at j equals target array of j minus 1. That's going to go all the way to the last one. Do I want to go to the last one? I don't want to go to the last one, right? I should do this while it's greater than this. And then finally at the end, this is going to go all the way. We should now just be able to do it at the index that we're on currently. So target array at index of I equals nums at I. Let me go over this real quick. I feel like I wrote some, kind of just like wrote this too quick for my own self. Okay, so we have the indices on top. So my target array is just going to be all these zeros. Okay, for I equals 0, this is going to be my target over here. We have our I. All right, so for let j equals nums.length minus 1, okay, so it will be nums right here. This will be our j right in the beginning. Target array at j, so this will equal target array of j minus 1. Then we go down one, then we go down another one, go down another one, then we're here. So then right at this point, we can just say that target array of index I is just equal to, do I still want to keep 0, 1, whatever's at I, right? Because then, yeah, let's see what this does for us. Return target array. I feel like I have like a bug in here somewhere. Oh wait, it's not gonna like these things. I don't have premium anymore, so this is gonna take a little bit longer to run. Like much longer. 04132. A lot of different test cases. 0, 1, 2, 3, 4, 1. So does this work? It might, but it's gonna go, okay. Somehow this was 49.82, but I'm not convinced that I'm doing a lot of calculations that I don't need to be doing. Yeah, so we can save some time here, right? So what did I do? Like if I haven't entered it some num at the index before, I don't need to do this. I don't need to do this shifting, right? So like that first one I answered, I haven't been to that index yet. So maybe what we can do, let's see, we get I equals index dot length. Okay, so here we can say if math dot sign of index at I is equal to 1, then here target array at index I equals nums I. If math that sign of index I equals 1, so at index I it's 0, first time there. Math that sign will return a 1 or a -1 depending on the sign of the number. So kind of like a cool JavaScript method to use there on the math object. So first time I use it, it'll be 0. Okay. And then what do we want to do? We want to, so else, right? Like if it's equal to 1, it'll come in here. Else, let's see, math that sign of index I, else, let's see, let's come in here. We just kind of space this out a little bit better. Okay, else, so it's negative, but I still want to get target array at index I. Not really the nicest way to do it, but I think if I just add a plus here, it'll make it positive. So I'm gonna run this and see what happens. Curious. Okay, 0, 4, 3, 2, 0. Let's see. If math that sign, so we get to math that sign index I, 0 is equal to 1, then we just know that the target array of index I equals the thing that's at nums I. Oh, and then we also need to make uh, index at I equals minus index at I. And I think this will just transform it. Yeah, well, let's see. 0, 1, 2, 3, 4, 1. So it's just this last one I'm getting stuck with here. Not this last one, but the first example. So let's go through it ourselves and see. Let's try this again. That's like the best way of doing it, right? So if math at sign of index I, just to make sure, I'll open up DevTools here, right? Just to make sure I'm not like, what is, oh, interesting. So I just learned something new. If it's 1 or 0, so math that sign of 0 is 0. Whoa, why did it copy all that? How will this run here? Of course, I messed up with my indices here again. Got even worse. Let's try again. Let's see. Again, best way is by going through it. Oh, but -0. It's not going to work for -0. Yeah. Well, I guess only if it's positive. So math that sign of index I equals 1, or math that sign of index I equals 0, and target array is this, and then index at I equals minus index at I. So this would be -1, and then we can increase this here. If math that sign equals 1, or, okay, that's fine. So we have a 0, and now we have a 1. Make this negative, increase. Again, it's positive, so make this 2. Then we make this negative, increase. And we say if math.sign, oh, we should, yeah, interesting. I'm not actually, I guess what we can do is like, will I really save on time if I go through the whole thing once? 0, 1, 2. Have I been, like I want to go to like where I've been before. Yeah, it's gonna be like, let's see, const previous index. Let's do const, or not const previous, let's do const current index equals index at I. I'm gonna create like a new function up here because this is getting a little bit unwieldy. So const is positive index. This takes in, just say idx, and we'll return this expression here, just so that way this will be a little bit easier to read. I don't like how all this is coming out. Okay, so if is positive index current index. Okay, so 0, 1, 2. If math.sign of index at 0, 1, 2 is 0. Right, so now when we get here, like current index will be index at this, which is 2. Pass in 2 here, 0, 1, 2. This is false. Now we'll do the shift. Else we can just say that target array of index I is nums I. So this should still be fine. But let's see what this does. Okay, didn't like something here. Const is positive increment equals idx. Yeah, I'm not even passing idx in here. 0, 4, 1, 3, 2, 0, 1. Oh man, yeah, maybe this is why. I know usually with these that are like heavily downvoted, it's because there might be some edge cases I'm not getting here, but I feel like we're definitely onto something. I don't want to spend too much more time on this because I do want to get to another question, but let's see. So it's failing. It's failing on which one? 0, 4, 1, 3, 2 is fine. Output, your input. It's giving me nums and index. So let's see these two nums. Oh, whoa. Nums and index. Let's mess with these guys here. Nums and index. Let's create our output here. Let's see what we can get. All right, so our j is there. Let's move our I down here. Okay, so we go to 1. Oh, but this is all over the place now, right? Again, I think I was like way too focused on just this nums, and I'm not even considering, because now when I go to 1, it just so happened here that things worked out really nicely for me. But then like, yeah, if I'm at 1 and I have already seen that, how do I know I've seen it before if it's not even in the right place? Like maybe a hash map can work here, but at that point it's like, I mean, should I go through all these and create a map? Maybe that will be easier. That will probably be easier. Where I just have, I mean, just for fun, let's do it. Let's have like index map. I'll just make this an object literal and not like a map or anything. For const index or idx of index. It's literally just going to be an index map of idx equals idx. That's all it's going to be. And now, inside of here, what we can do is positive index if map that sign. This will take an index if map that sign of index map of index equals 1, or index map of index equals 0. We'll do the same thing with target array. We'll check our current index. If it's a positive index, we'll set the target array, and then let's see, index of I. So I need to get index map of index at I equals negative index map of index of I. Looking a little bit crazy here, but you know what? This is how we learn. And I think that's a fun pursuit in and of itself. So yeah, a lot of stuff going on here, but let's give it a shot. I'm just gonna like run it, see what that even does. So same thing on top. So like we still get the same thing as before. Now this next one is messing up. So let's see. Okay, so also things are in duplicate. We have multiple indices. So this is just like, yeah. Yeah, I have a list of questions that I've been wanting to revisit, and I want to revisit this one because I know that we can do better, but I really do want to get to, so I'm going to add it to this Reddit stream revisit list I have. I think we at least got the, let's see, accepted. Can we just let's just copy this one. This is like very, very brute force, I think, but it at least satisfies the question and gives us something that we can work with. Let me just run this again. Submit this. Okay. 85.16. I mean, that's wild. I feel like we can absolutely make this faster. And I have a feeling it's gonna be at least one optimization is knowing whether this is the first time that we are inserting something in that index or have we already seen this index before. So just something to think about. Cool. Let's go to the next thing. So range sum of BST. All right. Binary search tree is great and a nice like to dislike ratio. So given the root node of a binary search tree and two integers low and high, return the sum of values of all nodes with a value in the inclusive range of low to high. Okay, so let's do it. Let's try to do it in two different ways. I think what it wants us to do, so low of 7, high of 15, for every number that has, for every node that has a value in between this range, we add it to like our ongoing sum. So I'm gonna do a little bit of a brute force thing here, and let's just like traverse the whole tree and then see. Let's think about how we can take advantage of it being a BST because that's really important. So I like to take advantage of default parameters. They're very helpful. Here, what can we do? We can say that if the root, if not root, so this handles null case, we can just return 0 here, and then we can say let new sum equals 0 if the root.val is greater than or equal to low and root.val is less than or equal to high. We can say new sum, or can we just add, let's see, sum will just be whatever else will come in here and add root.val. So do I even need this new sum? Well, let's see what this does. And then from here, we can just go, let's see, return range sum BST root.left low high sum plus range sum BST root.right low high sum plus sum. I think this might work. 97, beautiful. That didn't work. Let's see why that is. So let's say we get to, let's see, 7 and 15, right? Sum is equal to 0. Sum plus or equals, and then return. Is it because we're not actually returning? if I capture my sum, maybe that's what I was trying to do before, like let new sum equals 0. Um, new sum plus or equals root val. So we'll either return 0 or just return the new sum. Is this just going to be the same? Maybe I don't even need sum up here. 32, 32. Man, not having premium, you really feel that when you don't have it. I'm used to just spamming this run code button. 32, 23. Oh, I think it's funny that these are just reversed. Ooh, 10.69, which makes sense because this is a BST, right? We really should definitely be taking advantage of the properties of the BST here. So let's see what we can do. So we're in between, let's see. Do I want to take advantage? Do I want to like check my children to see if like any one of them, like if I'm like currently at this number 10, and this is in range, so I can add this. Then I'm at 5. That's not in the range, so I can just return. Am I, could I actually be, I can take advantage of like breaking earlier than I am. So like if not root or root.val is less than low, or root.val is greater than high, return 0. 25 and 10. If root.val is less than low, I don't even want to consider this, right? Return 0. So let's see, we're at root.val here, that's 10. Or root.val is greater than high. So it's not less than low, it's not greater than high. So if root.val, new sum plus or equals root.val, we'll go ahead and add it, and then we'll return root.left. This is less than low. Oh, but then we also don't ever consider, this is going to be a tricky one. But maybe what I want to do is just like check both of my children to see. Like if I'm at the 10, if at least one of these, well, if, why would I ever decide to venture to the left here? Like what other information do I have that tells me I should go to the left? I know that this is less than my low, but maybe there's something that's greater than high or greater than it going this way. Do I check like both my children at every step? Hmm. There's a lot of work that we don't need to be handling here. Like pretty much what I was doing was just processing. So it's what, a pre-order traversal, processing the node and then calling its left and right children, but doing that for the entire tree. So like I'm unnecessarily visiting nodes that I don't have to. So I get that piece. Now it's like trying to figure out, just trying to figure out when to go left or when to go right. Start at 10. We add 10 because it's between 7 and 15. So we say, can we go left? Well, does it, I mean, it can't, I mean, can we get as specific as saying, well, I can't go left, but if it has a right, like if, let me think about this. How many cases can there be here? Let's just start writing out some different cases here. Oh, I really, okay. So Root is null, we know that. Root is between the range. Root, because it can be root is not in range, but its left or right child is. So can the root be in range? But oh, so root is not in range, but right is, or root is not in range, but left is, if there's even a left. So when we get to the 15, I say this is in range, so I add this, and now what do? We can say uh, root is between the range. How do we decide to go next? We say, oh, is left one in range? No. If the right one is in range, then we can go that way. If the left one, no, I think I have to visit every. Yeah, I think I want to work with this. I'm going to comment this out and say, okay, so if, I'm going to be a little more explicit here. If root equals null, and I'm specifically doing a loose equality check here because this will catch null. I think this will just catch, well, in this case, since I'm loosely comparing it to null, it'll be null and undefined. Although I think just by, oh no, well, if that's undefined, it'll be null, so maybe we can just say strictly null. Maybe here we can return 0, and then we can say, let's think about this. Let me do the new thing I had before, new sum. So like if root dot val is greater than or equal to low, and root dot val less than or equal to high, I'll say new sum plus or equals root dot val. So if it's not in range at all, this will be like a nice, be out here. We can say var in range, num low high, and actually here we'll just return num greater than or equal to low and num less than or equal to high. What if here we said if it's in range? So if not in range, root dot val. Okay, so now if it's not in range, if it's not in range and it's less, I wish I had, oh, here we go. This was a little better. 6 and 10. So let's see how this would go. Okay, this is in range. Cool. So we add the new sum. If not in range, that's fine. We can just return this range sum BST. Come down here. This is not in range, but it's less than low. So if not in range and it's less than low, maybe we can say and root dot val less than low. Maybe we want to go to the right. Now this is always like one of those parts where I get confused with this binary search here. Or maybe we can do, yeah, return range sum BST root dot right low high. I wasn't even using sum anywhere, right? Okay, so if not in range, root dot val and root dot val is greater than high, return root dot left low high. And I wonder if here we can just do return new sum. Very curious about this. I'm not sure. I feel like I'm missing some addition here. But I like this one though. I feel like we're making some progress here. And to be honest, I've never thought of this question like this. So it's kind of exciting. I'm just gonna run this and see what we get. 10, 10. Okay, so I only added the first one. I never even got a chance to do the next one. Okay, So for equals null, return 0. Give me 1 second. I have to put my AC on. It's getting a little bit stuffy in this house. I have like the Nest, so I'm able to just do it on my phone, which is really convenient. Okay, cool. So if root equals null, return 0. It's not. So new sum equals 10. Root of also is in range, new sum. Okay. Now we also forgot, yeah, I guess we need to see, I should check both. Hmm. Like, do I always want to go to the left? Maybe I need to go to the left before I even, if I say this one's not in range and root.val is less than low, let's see, if root.left, now I think we're also missing on some returns here. If root.right, see what this gives us. Again, 10, 10. Not even making it to the next piece. Oh, root.left.val. Root dot. Oh, for all of these, right? Like if root.left, if not in range, root.left.val. I keep messing this up. Root.left.val. If root.right, root.right.val. Root.right.val. 2 zeros. Yeah, so what's like something cool about the stream now, right? We're getting to the point where some of these questions are now becoming definitely more thought-provoking, which is cool. I'm heading over to my whiteboard now because I really want to write some of this stuff out. Just to explain to people what I'm doing, since they can't see it on the screen, I am drawing out this tree on my whiteboard in hopes that having something that I can just at least mess with my own hands like this is going to make it a little bit easier for me to sort of like deal with in my head. Because my gut feeling is we're gonna have to like, okay, so right now I'm starting at the 10, right? This next one's asking us for a range of, I think it's 6. Yeah, so it's 6 to 5. So if anyone is like watching this, I would encourage you to pull out like your own pen and paper and try it out, and I'll guide you through like what I'm doing right now in my head to see if we can make some progress here. So I'm looking for numbers that are between 6 and 10, right? So if I get to the first 10, like the root of this node, I can add this because that's in range. Now I need to know to go left so I can eventually make it to the 7 because I need to put that. So to me it almost feels like at every node, let me check my left node. But what happens like if that node is valid or not valid, so whether it's in range or not, if it's in range or not in range, does that really matter? Like if it's in range, I'm going to visit it because I need to add it. And if it's not in range, I'm still going to visit it because I need to see, like I need to see what else is there for me to deal with. Now maybe I think it would be very like it would be too specific for me to I think do things like, oh, if it's like how I was trying to do, like if it's in range or if it has a left child, maybe instead of even worrying about if it's in range, I should just check to see if it has a left child. Right? So if it has a left child, should I always go to it? Again, I'm always going to end up in it. So let's say we just go to the 5 just because. Let's say we don't have any logic to take us to the 5. So right now I'm on the 5, trying to figure out what I'm going to do. Now I know I'm already in a spot that I'm not in range. Okay, so let's say if I get to a node that is not in range. If I'm not, yeah, I feel like it's the same thing as before, right? If not in range and it's less than low, then I should go right. So maybe what we'll do, or maybe can we do this? What if we did this in, would post order help us here? Post order might help us actually. If we visit the nodes first before adding anything. So let's think about this. If we can say that if it's not, yeah, if null, we can just return 0. Come to a node, we say if not in range, if not in range, and less than low, we go right. So let's say we started at 10, we go left, not in range and less than low, we go right. That is in range, so I guess if it's in range, we don't do anything. If we come down to 6, if not in range and it's less than low, go right, that's null. Okay, we end all that, we go back to the 7, now we add that, right? We came back from there. So I think something like that, maybe we can do a post-order traversal where like the information we get from the children is going to help us decide what to do on the way back up. So kind of want to like reset this whole thing again. Well, no, because I do want to keep my in range function, but I really want to remove all this stuff. It's just like noise to me. Okay, so I want to get rid of this sum over here. And now let's see. So if not root, we can return 0. If not in range, if not in range, root.val and root.val less than low, we can return range some BST. Let's do root.right, low and high. Same thing here. If not in range, root.val and root.val is greater than high. Let's return left. Else let new sum equal 0. If it is in range, if in range root.val, let's do new sum plus or equals root.val, and then root. What was I doing? Oh no, now I'm doing. Oh no, I think I was doing pre-order. No, post-order. I'm getting confused right now. Let me just like see what this yields, and then we can think about the different names for the different types of tree traversals. 0 and 0 again. When do we know? So let's just go through this, right? So range some root low equals high. So if not root, return 0. If not in range, let new sum equal 0. If in range, root.val, right? Num greater than or equal to low and num less than or equal to high. New sum plus or equals 10. Okay. Return range sum BST root.left, low, high. So let's go left. If not in range, root.val and root.val is less than low, we're going to come right. This is in range. So we come here. So let's think about this, right? We just like let new sum if it's in range. So that's the thing. Now we're not also adding. Do I want to create new sum higher up here? Like net new sum equals 0. Can we do new sum equals this? New sum equals this. Running it to see what it gives me. 0, 0 again. Probably really need to like write this out, but I feel like I'm making progress here. At least I'm taking some more advantage of the tree. Let's try again. So like for new sum 0, it's in range, so we add 10. Now we return. If I open up like a different, I don't think you guys can see. If we do Excalidraw, can I do like, oh, I can't do like, oh, let's see if we can draw this out quickly. 10, 5, 10, 5, 15, 3, 7, 13, 18, 3, 7, 13, 18. So 3, 7, 13, 18, and then 1 and 6 on the left, on the bottom. So we have 1 here, and then 1 here, right? Let's get our arrow. Number 5. Some nice shortcuts. Because I need to draw this out. It's the only way I'm going to be able to like really understand this. So 10, 5, 15 to 10, 5. Oh, and it even centers it. That's awesome. 10, 5, 15, 3, 7, 13, 18, 3, 7, 13, 18. Then was it 1 and 6? 1 and 6. Okay, so let's think about this algorithm we have here. What I'm going to do is I'm going to move the LeetCode off sort of like to the side here, just so I can see it a little bit better, and I don't have to keep going back and forth. Okay, so the way that I have it written out currently, right? So we can do here, new sum equals to 0. If not in range, that's in range. If not in range, so if in range, new sum plus or equals root.val, which is 10. Now we're going to return range sum of BST of root.left. So let's go left. All right, so now we have new sum is 0 here. Kind of draw this out again. New sum equals 0 because we just came left. If not in range, new sum is equal to, if not in range, 5, and 5 is less than low, which it is because low is 6. New sum equals range sum BST root.right. So we come to root.right. Okay. So new sum is equal to 0 again right here. It skips the in range checks. It says if in range, new sum plus or equals. So now this here is 7. And then I think I meant to put this. Nope, nope. Let's just delete this guy. Make it easier for us here. Get to the 7. In range, return range sum root.left. This is not in range. New sum is 0 here. Not in range, so it's back here. New sum is 0. If not in range, root.val, then we go right, which is 0, then we're done here. So I kind of see what's happening here. We get to this one, return range sum BST plus range sum BST, which we didn't really return anything really, right? New sum plus new sum. Let's just say that's 0. Maybe it's okay up here, but then when we come back here, if in range root.val and root.val is less than high. No, this should be greater than high, no? Either way, I never returned, or actually, did I just never get a chance to return that 7 up there? Let me see what this does. I'm gonna bring back LeetCode here. I gotta put it on the tab. Okay. Maybe that was, so I fixed this to be greater than high. Not sure. I mean, that's definitely a bug. Let's see if that fixed anything. 003223. So same thing. There's something, I'm definitely like overriding a value here or something. Or maybe I don't even need to be doing return all these different ones. If we just did returns here instead, this will be like the last thing I try for this question before moving on to the next one. Or I might just cap the stream here for now, see what this gives us. Might still give me a 0. Yep. Yeah, so why are we not new sum plus or equals root dot val? Yeah, I need to really like go through this. I probably need to do more of this drawing, but so where we ended off today, we were able to do 2 questions, both of which need a revisit, which I think is like good. I think it's good that we're getting to this moment where we want to like revisit these. Let's think about the first one. So this first one, create target array in a given order. We solved it with like a very brute force method. I think what we want to do now is go back and see if we can use the fact that like if we haven't been to this index before, we can just enter it, and if we have, we'll do the shifting. But I also really want to look into this upper bound right here, because normally when it's a small upper bound like this, it means that we can do something with it. There's some other storage that we can create that will allow us to do this in a much faster way. And then the range sum of BST, we were able to do this using linear time, but really because we have a binary search tree here, we should take advantage of the fact that it's organized in this way and see if we can get like a log n time complexity to make it go a lot faster. So to wrap it up, I went a little bit longer than I wanted to because it's kind of late here, but I really appreciate everyone watching the stream today. I see, we have some watchers and we have like a nice score going, so truly do appreciate everyone checking this out. If it helped you, or if you want to do the same and you want to follow along, let me just quickly explain for anyone that's watching to the end. So I started a YouTube channel where I'm uploading all these different videos, and what you can do is like this stream number 1 is essentially like your start here. I might even change the title to say like start here. And what you do is you can click on this. You can, before you even listen to it, you can just see the questions that I worked on. And if it's your first time on LeetCode, you can just open these up, attempt them yourselves, take however long you need, if it's an hour, 2 hours, 3 hours, a day, a week. And then once you've completed all of them, maybe you want to watch the stream to kind of get like my thoughts on it, see what I had to say about it. You might learn a thing or two. You might comment and like, tell me something that you learned or something that you think I should work on. Would love to hear that. Or you can also just watch the videos alongside me talking about it. So that way, hopefully it's a little bit easier for you to create the habit of doing LeetCode. I know a lot of us, probably people watching this stream now, we're all either looking to sharpen our skills or trying to transition jobs, and doing LeetCode is tough. So I'm hoping to just be that accountability buddy for you so you can check it out. So again, thank you all so much for checking out the stream today, and I will be back tomorrow for another stream. And hopefully we can get back to these 2 questions we did today and come up with some solid solutions. All right, thanks a lot, guys. Later.